Good morning, children. This is the math session for class 9 and we are continuing polynomials, and this is the fourth video in polynomials, and today's topic is remainder theorem presented by your maths teacher Padmaja. From your lower classes you have seen that you get a remainder when you perform division, and this theorem is definitely regarding that remainder only. Now suppose we are performing the division of polynomials, what we did in our previous class. When we do division of polynomials, at a certain stage we either reach 0 or a polynomial with degree less than that of divisor. When we reach to that stage, such a number in the dividend part whose degree is less than divisor, we stop the division and we call that number or call that polynomial or call that term as a remainder. So in this question, when we perform long division for x cube plus x square plus x plus 6 by x minus 2, we observe here that the remainder is 20. There is one more procedure to find the remainder directly without performing the whole division process. That is, suppose let us take the dividend as px is equal to x cube plus x square plus x plus 6, which is divided by a linear polynomial x minus 2. So instead of doing full division process for the remainder, we can simply find the 0 of the divisor and substitute that real number in place of the variable in the dividend. That is, variable 0 of the divisor is 2. When it is substituted in place of x in dividend, that is p of 2 is equal to x cube means 2 cube plus x square means 2 square plus x means 2 and plus 6, and thus we get p of 2 is equal to 20. Thus we observe that in our long division also we get the same remainder. So to get the remainder, we can do this process which is also called remainder theorem. To know the remainder of a division process, instead of doing the long division method, we can find the 0 of the divisor and that number should be substituted in place of the variable of the dividend. Let us see one more example of the division of polynomials, where the dividend is x power 4 plus 7x cube plus 5x square minus 4x plus 15, which is divided by x plus 2. See, beside a long division process is there, which was explained in the previous class. Try to do it by own and verify whether you get the remainder 3 or not. Definitely you will get 3 if you do it properly. Now let us verify it by the process that we have learnt in the before slide. That is, the 0 of the divisor x plus 2 is minus 2. Let us substitute this minus 2 for the variables of the dividend, where the dividend is px is equal to x power 4 plus 7x square plus 7x cube plus 5x square minus 4x plus 15. So the 0 of the divisor is minus 2. So let us see p of minus 2. Here it is plus 2 written, children. It is a mistake. While writing in your classwork, don't write p of plus 2. Write down p of minus 2. P of minus 2 is equal to minus 2 power 4 plus 7 into minus 2 cube plus 5 into minus 2 square minus 4 into minus 2 plus 15. Minus 2 power 4 is 16. Minus 2 power 3 is minus 8. Minus 2 square is plus 4. and minus 4 into minus 2 is 8. Thus, after doing the simplification, we got the remainder 3. Thus, we can understand that in this way, when we find the remainder, it is exactly equal to what we have done in the long division process. So, let us learn what this process is named as. So, this process of finding the remainder by substituting the 0 of the divisor in the dividend is called the remainder theorem. So, let us see. If Px is a polynomial of any degree greater than or equal to a be a real number, that means there is a real number a and this Px is divided by a linear polynomial x minus a, then definitely the Px is dividend and x minus a is divisor, then the 0 of divisor is a and P of a is the remainder. As in the previous problems we have seen, when the first polynomial is divided by x minus 2, P of 2 was the remainder, that is 20, and when the second polynomial was divided by x plus 2, the 0 is minus 2 and P of minus 2 is 3. So we understand that instead of doing whole division process, this remainder theorem tells you that how to find the remainder easily. Now let us do one example where you are asked to find the remainder when x cube plus 1 is divided by x plus 1. Now what is our process? First assume the dividend as Px. If it is in x variable, assume as s, or if it is in y, assume as P of y. So first let us take dividend as P of x equal to x cube plus 1. And what is the 0 of the divisor? X plus 1. It is minus 1. 0 means it is a number which when substituted makes its value 0. So minus 1 plus 1 is 0. So the 0 of the divisor is minus 1. Let us substitute this minus 1 in place of x in the dividend. So P of minus 1 is minus 1 whole cube plus 1, that is minus 1 plus 1, and the remainder is 0. See children, from our lower classes, we have learned that when the remainder is 0, the divisor is the factor of the dividend. Now let us see one more example where x cube plus 3x square plus 3x plus 1 is divided by x minus 1 by 2. This is one of the question from exercise 2.3, first question. Because it is a fraction, you feel it difficult to do, I have taken this as a solved example. Again, our first step is assuming the variable dividend is in variable x. So let us take Px is equal to x cube plus 3x square plus 3x plus 1. What is the divisor? X minus 1 by 2. What is the 0 of the divisor? 1 by 2. Now let us replace the variable of the dividend by 1 by 2. That is P of 1 by 2 is equal to 1 by 2 whole cube plus 3 of 1 by 2 whole square plus 3 into 1 by 2 plus 1. 1 by 2 whole cube is 1 by 8. 1 by 2 whole square is 1 by 4 and 1 by 2 is 1 by 2. So let us simplify and write as one fraction 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. Now this is nothing but addition of rational numbers where we find the LCM of denominators, and from our 5th class we are learning that if any one number is the multiple of others, the greater one is the LCM. So 8 is the multiple of 4, 2 and 1, so 8 is the LCM. And whatever number is to be multiplied by the denominator to get 8, same number is to be multiplied by the numerator, so that we change it to the like fractions. So it becomes 1 plus 6 plus 12 plus 8 divided by 8. So the final answer is 27 by 8. What is this final answer? This is nothing but the remainder when x cube plus 3x square plus 3x plus 1 is divided by x minus 1 by 2. So thus we have found the remainder using remainder theorem. Let us see one more example where two polynomials are given, 2x cube plus ax square plus 3x minus 5 and x cube plus x square minus 4 have the same remainder when divided by x minus 2. Then find the value of a. If you are unable to see the question here, you can see it is a question from exercise 2.3, which is also given as an assignment. That means these two polynomials when divided by x minus 2 gives the same remainder. That means in both the polynomials, when we replace the variable by 2, the remainders are equal. Let us assume the first polynomial to be px and second polynomial to be qx. Then the remainders will be, the variable will be replaced by the 0 of the divisor. What is the 0 of the divisor x minus 2? Yes, it is 2. So as the remainders are same, we understand that P of 2 is equal to Q of 2. P of 2 means in first polynomial replace all the variables by 2 and in second polynomial replace all the variables by 2. Thus, by doing the simplification, we get A is equal to minus 13 by 3. Every step you have to understand. Variable is replaced by 2 and then it is multiplied and then like a simple equation we are simplifying it. So it is the way you must solve such problem. In exercise, some similar one more problem is there. You have to do like this. And one more example which you may feel difficult, so I am doing here. Find the remainder when fx is equal to x power 4 minus 3x square plus 4 is divided by gx is equal to x minus 2 and verify the result by actual division. Here in this question he has asked you to do long division as well as remainder theorem and whether you get same remainder or not. So let's try to recall the last class where we have arranged the dividend in the descending order and whichever term is missing, we write that term with 0 coefficient. So in this, which terms are missing, children? X cube term and x term. So we are writing the dividend as x power 4 plus 0x cube minus 3x square plus 0x plus 4 when divided by x minus 2. Process of division is same like last class and we get the remainder 8. And similarly, when the dividend polynomial, that is fx, the variable is replaced by the 0 of the divisor x minus 2, that is 2, f of 2 is equal to 2 power 4 minus 3 of 2 square plus 4. Sorry children, instead of fx I have written here px. You write it as fx, no problem, whatever it is. So this becomes 2 power 4 is 16, 3 into 4 is 12, 16 minus 12 plus 4 is 8. So what we observe is, in both the processes, the remainder is same and thus the remainder theorem is verified. This is all about the examples and the theorem. And always a common instruction for you. Write down every slide as a classwork and then start doing the assignment. You can do it. Replace here the variable by the 0 of the given polynomials or linear polynomial. You will get some answer, that is the remainder. And assignment is not completed. Still in another slide assignment is given. You have to do these problems also. In these problems I have done 2 or 3. Remaining you have to do by own. You can do it once you understand. If you don't understand, go back to the video, again listen, Definitely every one of you can do it and do properly and neatly. Thank you children. Thank you all of you.